Hey everyone, and welcome back. Before we begin, make sure that you like and subscribe because it really does help out our channel, and it also helps us reach others in need of assistance with these topics. So what we're going to be discussing today is calculus, and we're going to be looking at derivatives of polynomials, and this will be part number 5. So we'll be solving these two equations, these two expressions shown on the screen here. And these two expressions are going to be solved using this formula here. So whenever you take the derivative with respect to x or any particular variable, and you have an expression that is a constant a times the variable you are taking the derivative of to the power of some value b. Well, this derivative will always result as such. Your constant a will remain constant, and then you have your variable x to that same power. Well, that power is going to drop in front of everything, and you're going to multiply through by it. And then the power is going to subtract by 1. So in most cases, our derivatives or our expression will not be set up exactly like this, so we have to turn it into something like that. So let's go ahead and get this started. So with our first expression, we have the derivative with respect to x, and then we have this entire expression of 5x cubed plus 4x squared minus 3x plus 2. Well, whenever you have expressions that are broken up by plus, minus, pluses, anything like that, what you are essentially saying is I'm going to take the derivative of this first part, and then I'm going to plus it with the derivative of the second one, and then subtract off the derivative of the third one, and then plus with the derivative of the last one. So anytime you have the pluses and minuses in there, you can piecemeal it out into separate parts. So this first expression of d dx of that entire 5x cubed plus 4x squared minus 3x plus 2 can be written like this. So you would take the derivative with respect to x of 5x cubed plus the derivative with respect to x of 4x squared minus the derivative with respect to x of 3x, and then plus the derivative with respect to x of 2. So you just take it 4 times, doing 4 different derivatives, and then adding and subtracting them all at the end. So each one of these is in some form of this ax plus b, except for this last one right here. And we'll get to that one at the end. So looking at our first one here of 5x cubed. Well, when we take the derivative, we're going to have our constant go through of 5. We have our variable of x to the power of 3. We're going to drop that 3 in front and multiply it by everything. And then after we do that, we're going to subtract 1 from it. And then for our second one of 4x squared, just repeat the process. Take our constant through of 4, our variable x squared. We're going to take that 2 and drop it in front, and then subtract 1 off of our power of 2. Then subtracting our next one, which is the constant of 3 carrying through, times x, and essentially this is x to the first power, so drop that 1 in front, and then subtract 1 off of it. Now here comes the last one, which does not have a variable x. So anytime you are taking the derivative of a constant, or just a plain number, you can just say it's a plain number of 2, well, there is no x variable in there to take the derivative of. So anytime there's no variable in the expression that you're taking the derivative with respect to, it just becomes a fat 0. So the derivative with respect to x of just a number 2 becomes 0 because there is no x in that expression to take the derivative of. So let's simplify this down here. So each term, so we have 3 times 5, which is 15, x 3 minus 1, which is x squared, plus 2 times 4, which is 8, x2 minus 1, which is just x to the first, so we'll just leave it as x, and then subtracting off 1 times 3, which gives me 1, x to the 0 power, which is essentially 1, so we end up with 3. So anytime that you have this kind of expression here, where you have the derivative with respect to x of some number times your value. Well, anytime this happens, as you can see right here in this expression, you literally just drop the variable and it just remains the constant at the end. So this is our answer for the first expression. So let's move on to the second expression of ddu of 1 minus u. So I'll just rewrite it right here since we can't see it up top. So the derivative with respect to u of the expression of 1 minus u. So once again, very similar process as the first one. We're going to take the derivative of each portion here with respect to u. So we have ddu of 1 minus ddu of u. And this one is quite easy and quite simplified here already. So if we're taking the derivative with respect to u of a number that does not contain u in the expression, it drops to 0, just like the first one here of ddx to 2. This first one of ddu to 1 becomes 0. And now we have minus the derivative of u. Well, this is essentially just 1 times u. And like before, when you have an expression that is just the constant times your variable with you're taking the derivative with respect to, it just comes out to be that constant value. So in this case, our constant is 1. Because this is essentially, if we want to write it out, it'd be 1u 1 minus 1. Which, that just goes u to the 0. We're left with 1. So essentially this expression, this boils down to -1. So sometimes these derivatives of polynomials are very simplistic. Sometimes they're a little bit harder, but these were not that bad. These are some of the easier ones. Just make sure that you remember if you have a large expression that has multiple portions in it that are piecemealed out as plus and minuses, you just take the derivative with respect to your variable for each portion and then add or subtract them back in together. So I hope this video was helpful. And if you want to see more problems solved of this variety, please check out the other videos on our channel. Also, if you haven't done so already, please make sure you leave this video a like and subscribe to our channel. Thank you for watching, and I hope you have a great day.